All right, let's look at Ostroff number 2. It's a good example of both using sectors and theta and stuff like we've been doing, along with doing the whole parabola thing where you get a quadratic, and whenever we have a quadratic, we can find the vertex to find the maximum or minimum. So that's what we're doing here. We have this sector, and they say you have $3,500. So you have $3,500. And you want to build a fence, and the outside, the dark one, is $5 per foot. Okay, I'm going to write this stuff down because I'm going to turn this off. So $5 per foot. And then this dashed one is only $2 per foot because it's dashed, so it's not a stick, I guess. And we want to know what's the biggest possible area you can make then with your $3,500. So you're, right away like, well, they don't even give us theta, the angle or anything, right? But, well, it must be doable. So what you gotta do is start labeling things and start writing things down, and things come together amazingly. So first, let's call the angle theta, because we gotta do that. We'll call the radius r, and so of course the radius of the small one is r/2, but we'll call the big radius r. And now let's start writing some things down and hope that something works out. Okay, I'm going to turn this off. I don't think we need this anymore. I want the maximum possible area. Okay, there. Oh wait, I should outline my sector. That would be good. So here's our sector. And dashed one here. All right. There we go. So what can we say? Okay, area. We want to know the area. Ostroff number 2. So let's see. The area of any sector is the fraction of the full circle that we have. Right? So the full circle, of course, is pi r squared. Right? That's the full circle. Well, we have only theta, which we don't know what it is, but oh well, it's theta. So we have theta over 2 pi, right? The fraction we have of the full circle. The full circle would be theta equals 2 pi. We're probably going to have a smaller amount than that. So we have theta over 2 pi. Okay, this is our total area. The fraction we have of the full circle times pi r squared. Right? The full circle is pi r squared. Okay, the pi's cancel. So it's just 1/2 theta r squared. So that's kind of a nice formula. 1/2 theta r squared. Now we don't know what r is, we don't know what theta is, so you're like, okay, well, so that's great, but what are those things? Okay, we also know the perimeter, right? We know the perimeter and what it costs. So let's see. For the perimeter, the cost is the outside, which is r plus s. Right, and this s, this arc length here, is always r theta. Right, the arc length here, that's the definition of using radians. This always works. Of course, we're going to be using radians here. So s is equal to r theta. So the cost, which we know is $3,500. So $3,500 is equal to $5 times $5 per foot times the outside, which is r plus r theta. I'll just write it all out. R plus r theta. $5 for the outside, so we have 2 r's, the 2 radiuses, and then the arc length, plus $2 per foot for how many feet this one is. Well, that arc length is r/2 theta, right? This one here is s equals r theta. R is the radius, that one's r/2, so r/2 theta. So plus 2 times r/2 theta. Well, we can certainly simplify that. So I get 3,500 equals, let's see, this is 2r times 10. So that's 10r, right? Yes, 10r plus 5r theta plus 2's cancel, so plus r theta. Let's see, the r thetas can go together. So finally we have 3,500 equals 10r plus 5r thetas plus 1r theta is 6r thetas. Okay, cool. So we have two equations and two unknowns. We don't know theta or r squared, but we have two equations here. And what we want, of course, is the maximum possible area. So let's see, which one should we solve for? There's only one theta here, so maybe I'll get rid of the theta. That's probably a little bit easier. So let's solve for theta here. So 6r theta is equal to 3,500 minus 10r. So divide both sides by 6r. So theta is equal to, what's 3,500 divided by 6? 3,500 divided by 6. It's got to be ugly. 583.333 forever. So 583.33 forever divided by r. Right, because 6r, put the r in the bottom. This one divided by r, the r goes away. That's really nice. And that's what, 10 divided by 6, which is 5 divided by 3, which is 1 2/3. So minus 1.6666 forever. Did I do that right? 10/6 is 5/3. 5/3 is 1 2/3. Well, yeah, I think that's right. I could put a 7 here eventually. We'll keep lots of decimal places. Okay, that's what the angle is. Yep, r in the bottom there, r's cancel. Cool. Now we can take that, plug it into here, and let's see what happens. So 1/2 of theta, which is this, 583.33 divided by r minus 10r minus 1.6667. I should just leave that as 5/3. Whatever. Yeah, I'll do it as 5/3. It's easy to write. Minus 5/3. That's times r squared. Okay. Let's see. Let's multiply the 1/2 through and the r squared through. The r squared cancels out 1r in the bottom there. And I'm running out of room. I don't think I need this picture anymore, right? We know what we need to know. So I'm going to erase the picture. You guys should have it down anyway. Yeah. Okay. So I don't need the picture anymore. So now it's just algebra. So let's see. This is equal to half of, oh really? Okay. Half of 583.333 times 0.5 is 291.66666. So 291.66 forever. Put a 7 there. Let's see, the r squared, so that's an r then, because the r squared divided by r takes away one of them, minus 5/6, right? The 1/2 makes out of 6 in the bottom. So minus 5/6 r squared. 1/2 of 5/3, 5/6, yep. Okay, that is our quadratic. Cool, like we knew it had to be, because to find the maximum or minimum, we know it's got to have a peak like a quadratic does. So now we just got to figure out what the maximum of this thing is. Okay, what is the maximum of this? Now, it's a negative r squared, so we know it opens down, so we know it's going to look like this. So we want to find that peak there. So of course we know that peak's at negative b over 2a. So r is negative b over 2a, which is, b is this, 291.666 forever, whatever. So negative b over 2a. A is negative also, so that's over 2 times 5/6. Negative 5/6. So negatives cancel, which is good. We don't want a negative radius. That would be kind of weird. Okay, so now we just get a number for that. I should have tried to change the 5/6 to a decimal, but whatever, I can now. Okay, now this is going to be tricky. So 2 times 5/6, that's 10/6. Let me rewrite that. So that's 10/6 in the bottom, which is the same. Instead of doing that, dividing by 10/6 is like multiplying by 6/10. Right, so 10/6 in the bottom is bottom, the bottom is on top. Yep, that's right. So 291.66666 forever. 291.6666666. times 6 divided by 10. Ooh, it ends up being a nice number, 175. So the radius is 175. That's what gives us that peak. Now they want the area, unfortunately. So we got to plug back into this formula, right? That's what the area is equal to. Yeah, so we take our 175, plug it back into here. So the area is equal to 291.666 times 175, that's this part, minus 5/6 of 175 squared. And let's see if that's a pretty number. I gotta do the whole 291.6666 thing again. So let's see, 175 squared times 5 divided by 6. I get 25520. Let me write that down. So this is 25520.83333. And then this one, 291.66666 times 175 is 51041. 51041.66 forever. So take away that from it, and we have an answer. Minus, almost there, 25520.833. And I get 25520. Wow, it ends up being exactly double that number. That's crazy. So this number is exactly double that number, because what you finally get is 25520.833 or so. So let's just write that down after there. Okay, that is our area, finally. And I don't know what the units are. Feet, doesn't really matter. But it'd be feet squared or square feet or square meters, whatever the unit was. Okay, so there you go. So the trick here is 2 equations, 2 unknowns. They don't give us an angle, so that's one of our unknown. They don't give us radius, that's one of our unknown. And the 2 equations are the area formula and then the money formula. We have $3,500, which is the perimeter formula. The perimeter, and then multiplying by the cost. So it's per foot heat. All right, cool. Yeah, excellent problem. Cool, thanks for watching.